wanted to talk about moving from communication service provider, and that's a new term for me, to digital service provider. Because the world I come from, I'm more on the IT side. CSP stands for cloud service provider, so I have to straddle both worlds here when I talk. And what I want to do is talk a little bit about automation is key. And if you've all seen the first chart, I'm going to skip it quickly because I think that's a repeat. And then I'm going to move forward into our high-level architecture, which now I see very well matches the architecture being promoted here, which makes a lot of sense. It, to me, brings in some very important elements like separation of concerns, the ability to flip out one piece for another, leave the flexibility to the designer to build certain parts of the architecture. So I'm very happy to see all those principles are showing up, here in this workshop. And then we'll take a look at some of the other results I have from our surveys, which are different. Some are different than what I showed this morning. And so our architecture, of course, as this morning, started with SDN and NFV as a base technology, which in my mind was all about getting to automation, but we had to do things in the network first. Then we talked about automating. It's our belief if we don't simplify, we can't automate. You can't take something complicated, try to automate it, and then all of a sudden it becomes less complicated. You just get into trouble. We have to put certain simplifications in the network first, then we can move over to the automation stage, which I mentioned this morning. And then, of course, there's the concept of zero touch, which is very important, and we've seen some important learnings already in this workshop in the last couple of hours about how intent gets included, as I mentioned, an architecture and principles that make a lot of sense that will help us succeed. The idea of closed loop in many domains. And then, of course, getting to the goal of a digital service provider. And with that, this morning I talked a little bit about our architecture. I talked about intent. Other people had the same concept as I've been pushing, which is say what, not how. And I think we're all on the same page. I'm happy to find that out. I must say that I still go to conferences where people use the word intent, and they cannot say what, not how. They still are, in my mind, missing the point. So I'm happy that's not the case here. And with our map of the domains and the multi-domain controller, we see this as being logically centralized. Now, we did have a comment, which makes a lot of sense. This really looks at one communication service provider. Obviously, these would federate in a cross-service providers. And then, of course, we need our service models. We need our device models. We need to get visibility, all sorts of visibility information. Probably terabytes of data will be coming off the network, even petabytes. From a computational standpoint, my team looks at how are we going to store, where are we going to store that all? How are we going to process that? What portion will be at the edge, processed there? What portion eventually is going to be centralized? So those are the kinds of things that we research and look at. I don't have a number to share with you today, but in the near future, I'll be back with some concepts around where do we think the distribution of compute is going to be 5 years from now? How will it look when we look at edge versus centralized? And then, of course, we need to look at some of the analytics in the field. And I think I mentioned this morning, and I'll say it again, we've seen a whole set of new types of compute engine servers with different packaging now coming from the vendors to look at harsh environments at the edge, different form factors that are going to be needed in a communication service provider perspective, UCPE appliances. All these things are going to be part of what's going to be at the edge. How much are we going to do at the edge? Are we going to put GPUs in them? And are we going to be looking at inference at the edge? I bet we are. And in fact, I made the prediction, and we'll see if it's true coming back in a year or two from now, that your typical router or Ethernet switch will have silicon in it for AI, and we'll do inference right in those components eventually. Just like in the past, They were pretty hardwired. Then we added x86s, wrote a lot of software on these devices. GPUs are just a natural extension. And when I did ask the device manufacturers, when will I see a GPU? They didn't answer, but they didn't look at me and go, no, that was a bad idea. So I suspect we're going to see that. And then, of course, gets us to our cycle of automation that I talked about earlier. This is a new one. So we took the ETSI ZSM goals, and we asked service providers what was their priority. And we asked them to rate the goals, 6 or 7. And 60% of respondents said that getting a realistic migration path from where they are today to implementing zero-touch automation was really important. And they were looking for this workshop to help them figure that out. These ones look like they're the same. They're not actually. When I shortened it, I made a little goof. This is talking about cloud native, and this is 5G slicing. And so the next one was define an end-to-end network service management function architecture along cloud native principles and being able to interact with the cloud service providers. So that was right behind in terms of the goals. And then, of course, you can see the rest of the ordering all the way down to the multi-layer resource management. So I thought this workshop would be interesting to see the results. And I think I said it earlier this morning, but I'll say it again. We surveyed 25 service providers, representing 45% of the CapEx spend. We think that even though 25 is not a high number, we have a pretty good representative sample. Let me see. Okay. There was a lot of worry also in our survey about the state of readiness. The top one was the service providers were telling us our back-end systems are just complicated. We don't know how to make the steps to automate. We're worried that there's just too much, it's too big a mountain to climb. So we need to find a way to not have to climb that mountain. 48% company just not ready. Organizational structure's not there, the skill sets are not there. Too much inertia in terms of desire to change versus ability to change. Still worried that technology's not ready. We could see in the workshop here, we made good progress so far. We still have a ways to go to make it easy. And then, of course, there's cost, and some people will not trust automation, so I'm very happy that we had the concepts around closed loop is nice, but there has to be some sort of option for not totally closed loop, some sort of check and balance in there. Let me see. And then, of course, where to automate. Well, this is a picture I showed earlier. This is showing our view of where edge computing starts or stops, and then where the central computing might be. And the fact is, we have to automate across this entire spectrum, from edge to center. And that's part of what I wanted to talk about. And then there are all these places that are edges, right? Whether we're talking about UCPE at the enterprise edge. I look at that as the enterprise edge. It's sitting in the DMZ of an enterprise. We have all the devices in the field. I think I mentioned this morning that I had spent some time at a conference just recently because IHS Markit happens to be very strong in the energy sector. And I spent time listening to people working in the energy, in the oil fields, about how they're instrumenting the drilling rigs themselves. So now that as the drill is actually boring a hole, the sensor data is coming right off the rig, and they're actually wanting to process it right on the spot because they can get, from the vibrations of the bit that's going through the rock, they can actually get a seismic picture of what the field looks like in real time. And that's way better than what they had in the past, where they could only do that over a long period and had to guess about where they were putting their bits. So there's a lot of advancement in real-time data in many fields, and I just believe that the energy patch will be looking to communication service providers potentially to help them with that. So it's just one vertical that I wanted to mention because I happened to learn about it very recently. But we have all these edges, and automation has to go across all of these places. Then I mentioned simplifying to single network, and we talked about intent. And I think that will go a long way to bringing things together for designers. And then some of the simplifications are bringing some of the different multi-domain orchestrators together under one roof. And then also bringing together some here under one roof. So provide levels of abstraction, not deal with all the orchestrators independently. Here's another one where we think there's room for fixed and mobile conversion, so flattening the network, making it simpler because of the higher levels we don't see all the different domains. And then, of course, the optical transport and the network. Packet and optical, we already see that merging together in the industry, again, bringing a simplification. And then I think I showed this one this morning, but effectively getting the telemetry, deciding where to process the telemetry, providing instant feedback if you could, across the different merged domains, bringing in security, and then the feedback from the OSS BSS to complete the picture. I think this morning I said that, for my mind, there'll be no 5G without automation, and actually I heard that echoed after. And I think we all agree that there's a massive amount of complexity with what we want to achieve. And it goes all the way from virtualizing the RAN, understanding what speed that goes at, where do we put the compute, do we move some of the functions from the edge centralized, and how do we make this all work, including the actual slicing of the physical devices, given that we're seeing new silicon in the market that will be able to handle the slicing in new ways, which will also be programmable. If many of you may be familiar with some of the new silicon coming out from companies like Barefoot Networks that are now opening up a whole world of programmability right at the physical layer. And then, of course, some of the other use cases for 5G where complexities are going to come in. Look at the concept of wanting IT for everything and a slice. We talked about that earlier. We talked about critical machine communications, and we want instant action. We need reliability and low latency. The autonomous vehicle is a favorite use case. And then, of course, the broadband experience as well, an ultimate ultra broadband experience where it's more about data rates and capacity and guaranteeing those high data rates. So just 3 different use cases, very different requirements that we're going to have to meet. Just wanting to talk a little bit about how it's diverse, and dealing with all that means it's not humans that are deciding how to make that happen. So now I'm going to change gears a little bit. I'm going to go a little bit into the world that I'm a little more familiar with. I spend a little more of my time on the IT side, and I want to talk a little bit about cloud. Now, I know we're talking about the communication service provider becoming cloudified. Well, we have cloud in the IT side for many, many years. And one concept maybe some of you are familiar with is the multicloud. Well, the multicloud is already happening. Enterprises today are already using multiple different cloud service providers. They may be going to Amazon because they like certain cheap compute instances. They may be using Microsoft Azure because they like the ability to program the FPGAs that Microsoft offers in their instances, or they want to use TensorFlow from Google. So they have already reasons to go to multiple cloud service providers. And in our surveys, on average, enterprises tell us that they're using 10 different infrastructure as a service providers. And they expect that to hit 14 in the next 2 years. So, and when I first did this survey several years ago, my intuition said, well, maybe I'm going to get 4 or 5 as an answer. I already got 7. And this has been consistent over the last 4 or 5 years, so it's not an anomaly. It's been slowly creeping up. And so the reason I wanted to talk about the multi-cloud is, as the cloud communication service providers cloudify, I've already started to get questions from my clients, which I don't have the answer to. Are the communication service providers going to build everything in-house? You're going to buy all your own servers, and are you going to run all your own data centers? Or are you going to go to Amazon and Google and the cloud, which ones, and put some of the computation you need there? And if so, how much is the question I'm getting. So this is something that but I wanted to talk about the multi-cloud because I think that we can look at and learn and understand what's going on in the enterprise as we cloudify the communication service provider. And then the next thing I said is, well, you know, we're all talking about machine learning and AI, and again, are we going to borrow anything from the cloud in terms of all the advancements with neural networks, all the advancements in machine learning that are available as libraries that you can get started with today, and the GPU instances that are already available in the cloud? Just to give an example, we had Amazon and Google. I showed this morning. You can get the same, very similar things in Azure and IBM, and a lot of commonality around interfaces. Okay, this one came up funny. Essentially, what I was trying to show here was, this is enterprise, this is communication service provider, this is cloud service provider, this is who bought different servers in 2017, and where we forecast this will be in 2022. The important thing was, enterprise stays about the same in terms of number of servers they're going to buy, of the total spend, of total number of servers shipped. However, both communication service provider and cloud service provider grow, and this is to capture NFV plus all of the cloudification of telco. So we actually see the cloud communication service provider growing significantly in terms of their share of market, in terms of buying compute. The other thing I wanted to share with everyone is this is percent of servers shipping with no coprocessor, and this is percent shipping with a coprocessor designed for AI and ML. It's a 2% for 2017. Apologize for the slide. And here, we forecast that by 2022, 15% of all servers shipped will have silicon in it for AI and ML. It could be an FPGA, it could be a GPU. And for the most part, we expect that the majority of those will be in the cloud service providers. However, we are now allowing for some percent in the communication service providers. And if I project past 2022, my bet is that the communication service providers will take a growing share as they roll out what we're talking about, automation component. And so I think I'm at the key takeaways and right on time. So I think we agree automation is an imperative, that we need to look at the concept of multi-cloud, which, by the way, includes on-premise. That's part of multi-cloud, which I didn't say earlier. And can the communication service providers, as they plan the cloudification, how do they build their multi-clouds? It shouldn't all be an on-premise discussion. And last but not least, I believe that AI and ML is cloud-led, and the communication service providers will be in good company to start leveraging all that's available in the cloud, and then patriate what you need to on-prem going forward. So that's my thesis, and I'm leaving you with that. And so with that, I think we're ready for the panel, and I'm going to move my chair over, and I think Narit is going to call some people to come on up. Here's the clicker to advance the slide, so I'll just leave it right here.